Good morning, Ishan. Only you have come, I think. But anyway, let's start with the lecture because I have one meeting also. The department is holding an online meeting at 11:30. So I would like to just go the uh, through this portion because only these things are written in your syllabus. So I thought let me do here the data structures that I will cover today are sets and maps. All right. So basically, set is a data structure, but we will use to implement the sets. We will use the binary trees only. All right. So we have already covered binary trees. And as far as the coding part is concerned, as far as the understanding of binary search trees are concerned, I think we have already done, and there is no need to go into the details. But let's see what a set data structure is. Now, the first point is that we use binary trees for creating a set. All right, a set is a data structure that is used to test membership. Meaning by a set contains certain values. Whether when you check whether a particular value is present, so that means the value is a member of that set. If it is not present, so it is not a member. I mean, you can check. Set will contain certain values. You can check whether the value is present there or not. The condition for sets is that sets do not have any duplicates. That is, its values are all unique. Meaning by that whatever the values will be there in the sets, those values will be unique. No duplicates are allowed. Of course, in binary search trees also, if you remember, no duplicates were allowed when we created the tree and implemented using some code. So here also they don't necessarily have any order. So the values present in the set cannot have certain order also. They can be just present, need not to have a certain order. So if you use Java programming, a set based on a binary tree is called a tree set. So we have a tree set library there. You can use that library in the Java programming to create the objects and so on. Now, since set is a data structure, what are the operations that can be performed using this set data structure? So I have written down some of the operations which you can perform in a set data structure. As I said, that set is having values only. Set is a collection of values, right? You can add any value. The first operation is add value. So you can add any value into the set. So this operation, as far as the coding part is concerned, that will be done through the binary trees only. The programming part I have already covered for the binary tree. But the operation can be adds a value to the set. So in this operation, you can add a value to the set. Now, if it already exists, if the value is already present, then just replace it. You cannot place a duplicate value in the set. Now, since you have to check for all the values, right? So if it exists or not, since you have to replace, and you are implementing a set using a binary tree. So what is the search timing required for a binary tree? It is log n. So if you implement a set data structure using a binary tree, the add operation will take log of n. Similarly, for remove a value from the set. With a binary tree, you have to search for the value and then you have to remove it. In that case also, it will take log n time, right? The third operation can be Boolean contains value. Meaning by Boolean contains is a function value that you are looking for, which can be present in the set or not. So Boolean contains will be a function. Now it will return true if the value is in the set. If the value that you are looking for is present in the set, it will return it true, otherwise it will return false. Again, this function will have to search through all the elements in this set, right? So it will take log n of complexity, timing complexity. The next operation can be int size, meaning by what is the size of the set. So you will have to go through all the three operations. The first three operations, since we are implementing it through a binary tree, so they are taking log n of time. But because all the three involve search operations, but the last one, which is the size of the, you will have to know how many values are present. You will have to count basically. So it will take the O of n amount of time. Return the number of values in this set. What is the number of values present in this set? All right. So this is the set data structure, very simple. Only thing is that this set data structure will be created through binary search trees or binary trees, right? So I thought that let me just have introduction of what is the set, because these things are mentioned in your syllabus. Now the next type of data structure which is left, again a small portion is there regarding maps. Now let's see, set is a different data structure, maps is a different data structure. Maps actually is a very important data structure which is used in many of the programming language, which the feature is given in many of the programming languages, and very commonly used in cloud computing, where the operations are distributed among cluster of computers. All right, so you will have to map the computational part to different components in the cloud. But anyway, we are not dealing with those things. So let's see what is a map data structure. Now, if you remember, I have just covered it. Sets only have values, only values. Now, maps are like sets, but instead of just values, a map stores values based on a key. So there will be a key, corresponding to that key will be values. All right. That means there will be key value pair in the data structure. The data structure is something like key value pair. For example, let me give you an example. Let's say you have a table, right? First column in the table is the serial number, next is name, next is roll number, right, and so on. The next may be marks, right? In this case, the serial number, the name, roll number, these are the keys. Now, what are the different values in the against the keys will be in the inside the table, right? So this is known as the key value pair. These are known as key value pairs. Now, we can call the relationship between a key and its value as a mapping. Why these are called as maps? So key and value, there's a mapping between the two as a mapping from key to value. All right. Maps also don't have any duplicate keys. There cannot be duplicate keys, and the keys don't have necessary order. So there's no necessary order for the inclusion of certain keys into the data structure. We use a map to store some value based on a key and retrieve it later based on the same key. So against the key, the values will be stored. So we can also retrieve the values just by inputting a key. We will be able to retrieve the value. Now, in some languages like Python, in some languages, maps are actually called dictionaries. So in Python also, if you know, you can have dictionaries present. So those are basically maps only. But once you use those dictionaries, the programming structure, the flexibility of the program becomes very important, and you can include lot more things into the in the name of dictionaries. Basically, those are maps only. In Java, a map based on a tree is called as a tree map, right? So in Java, it is a tree map. In dictionary, in Python and other languages, it can be dictionaries also. But these are the examples of maps only. Now, a map will have the following methods. The first method means operations basically, because in Java and other languages, there will be a library corresponding to map data structure. And for example, in Java, it is tree map. So you can use these methods out of that library. The first is the put. Now, put means you will have to enter the key and the value both. Add a mapping from the key to the value. If the key already exists, replace the key and the value. Just add the value into the map. With a binary, if you are implementing it with a binary tree, it will take log n, because you are entering a key value pair. Value get corresponding to a key, retrieve the value mapped from the specified key. So since it is a tree structure, again it will take log n. So you are given a key, you want to retrieve the value corresponding to the key. Now remove key, you can remove the specified key and its associated value. Again it is log n. Size, what is the size of the map data structure? Retrieve the number of unique keys in the map. It can be O of 1 if you are separately storing the values of keys. Otherwise, it will take O of n. But I was going through the program on some of the websites. So they used it as a buffer. They were counting the number of keys and all, so they can directly retrieve the values in a single go. So it was O of 1. But if you want to see through all the elements in the map data structure, so it will take O of n. All right. Now this finishes my basically the sets and maps. Basically, these are two different data structures, more organized data structures, but the basic data structure inherent into these will be your binary trees only. So you will have to implement the sets and maps using binary tree. But for implementation sake, we can classify these data structures as sets and maps. Now, if any questions are there, you're most welcome to ask any questions, or if you have any doubts regarding the previous labels and all, you can ask. You can unmute and you can ask the questions. Or let me unmute everybody if I can. Sorry. I'm not able to unmute from here. Okay, you can ask the question through chat if you want to ask any question. Please go ahead with your questions. Okay, then I will close the meeting, because I'm waiting for another meeting of the department, which will start around 11:30, right? Even anytime, if you have any questions, any doubts, you can either email me, you can call me, you can WhatsApp me. So no problem with that. All right. So I'm always available. You can ask me any questions. Anyway, thank you so much. I will share this video also. Thank you so much for the meeting.